Hello, Professor. For the fourth assignment of data science, I've used IRIS dataset, and what I've done here is predicting species classification and decision boundary visualization. So the idea is to use the chapter 4 training models like with algorithms like decision tree, random forest, k-nearest neighbor, SVM logistics. So initially I'll go with the decision boundary visualization plot. So the decision-based decision boundaries. Here we are plotting the decision surface of these the three species in the iris dataset, and we are using a logistic regression with the mesh grid plot to see how the classification has been done. So here, if you see the decision tree, random forest, and the extra tree for these three species has been plotted, and we could see the accuracy. The main idea here is that the blue dots, how correctly it is falling under the red roofs. So here in the first case, it is cutting off few plots here, and we could see the accuracy is 70%. However, in the extra tree model, it is fitting it better, and we get a higher accuracy. And likewise, so moving on to the decision boundaries, we see overfitting efforts on the decision boundaries. Here, when we run the logistic regression, we see that when we use a depth of 4, we see that the plots are much scattered, and when we use a higher depth, we see that there is a overfitting happening at this area, as it tries to make sure like everything is falling under the classified boundary. The other one is the regularization efforts on the decision boundary. In this area, we are seeing that the logistic with the regularization of 3 different values, we are taking only 2 features in this case. So on the first regularization of 0.01 value, we see a classification which is highly classified between zeros and ones. On the other case, like if we increase the regularization C value, we see that there are plotting area between the 0 and 1s, and these are like non-classified species, or not correctly classified species. These are like whether the above ones show which area the plots are figured in, the whether it's on the 0 side or on 1 side, but it doesn't give us a probability. For that, we use the class surface probability. So we have 3 different class surface probability, as you see here. And moving on with the prediction model, we initially plot the 4 different features of the data set, and now then like we run through the violin plot to see what is the average of the values, and then like further we plot the correlation between the features, and we could see a high correlation between petal width and petal length. So we will do training testing on different algorithms with all few 4 features, and then with the eliminating the highly correlated features. So with the first one, we run the SVM, logistic, decision tree, and k nearest neighbor. We see all having a pretty high accuracy of 0.97, 0.951, and so on. So this is with uh, all 4 information features. Like moving on to do with only 2 features, that is petal length, petal width, sepal length, and sepal width. We again do the SVM, logistic, decision tree, and k nearest neighbor. So for the petals, we see a high accuracy rate, at least accuracy rate better than sepal. So in all the cases, the accuracy of sepals are lower. So we can conclude that the petals are the best features in this case to predict the classification of the species. Thank you.